Hello and welcome in. My name is Mark, aka the Markster. This is video number 6 in the FreeCAD series. Let me verify that. Yes, video 5 was the last one that we made. So this is video number 6. As you can see, I'm well prepared. We'll be making this model today. We're continuing our coverage of the part workbench, and we've covered the cube, the cylinder, the sphere, the cone, and now the last of the primitives that we have here on the toolbar, the torus. So we'll make this model today. Go ahead and close this. And let me show you, I'm using a new version of FreeCAD. I just updated it yesterday. 0.19, 19.5.10. The previous videos are all made with the version that I showed. I think it was in video 1, which was also 0.19, but an earlier Git version. Create a new document. I'm going to dispense with the spreadsheet for today because we've shown the spreadsheet several times, and I want to focus on showing the new topics and not so much continuously doing the same thing over and over. But we will be using the spreadsheet again in future videos. So let's bring in our torus. Torus, once again, is a donut shaped or maybe a lifesaver shaped, inner tube shaped object. We have two radii values. One is represented by this seam line here. That would be radius 1. And the other by this circle here, which is radius 2. We have 3 angles. If we scroll these angles, we can see what happens. Let's go down to 160. Press F5 key to refresh, and you can see what that does. And the other works on that top angle I hit above the seam. So basically you're changing the starting and ending angles of this circle is what you're doing with those first 2 angles. Let me put them back on default. Back to 180 here. This angle, let's go to 180. And I'm actually going to use 90 degrees. I believe I actually used 60 on the other. I'm also going to introduce the concept of attaching objects to other objects. Many objects in FreeCAD are attachable. Most of these primitive objects have an attachment mode, and by default it's deactivated. let's add a cylinder. And let's set the torus, let's set this radius to 5 millimeters. Radius 2 of the torus. And the cylinder to also 5. Alright. Now we can select the cylinder and we can select its map mode here in the property view. You see this button that pops up with the 3 dots? Click that and it brings up the attachment task dialog. So we're going to attach the cylinder to this circle here, this edge. And we'll come down here and tell it to flip sides. So flipping sides just means we're going to use the other side of the cylinder. We can also do some adjustments to the attachment offsets here. For example, we could move slightly in any of the axes, or we can rotate. Put it back to 0. You see how that's working? And this one, get around to the seam. We can rotate that seam. Sometimes, if you have your seams lined up like this, it can cause a problem with a Boolean operation if these seams are together. Sometimes it works, sometimes not. If you are having a problem with the model and is failing some Boolean operation, look for seams like that, and you can often rotate to avoid that. Put it back at 0. And OK. F5 to recompute. And now we see that our attachment map mode is concentric. And we have map reversed equals true. And we also have something in map path parameter. This is a value between 0 and 1 that many times can have a difference. I don't know if it's going to matter on this particular one, but if you were aligned to an edge like this, between 0 and 1, it could move your object along that line. Got another cylinder. Like this one also 5. And we'll attach it. Select the object, select the map mode. You can map to faces, to edges, to vertexes. Some prefer vertices, but either spelling is acceptable. These are the map modes available. Concentric is chosen by default when you select a circle. We can look at some of these other modes and what they do. And if we selected that mode, we could rotate. We could rotate 90 degrees and also move in whatever direction we like and get it lined up that way too. But there's no point if we have a mode that works at the default values, concentric in this case. Often I just experiment with various modes and offsets until I get what I'm hoping to get. So the advantage of attaching is you get it lined up like you want it, but also it's a parametric thing. So if we change this angle again, let's go back to 90 for example, everything stays lined up. $120. I think $120 is what I used on the other model. And now we can add a third cylinder. This one we can make it a little bit smaller at 4 millimeters and a little bit longer. And we'll select this face to map to. Let's first select our cylinder. Map mode deactivated. Click the 3 dots button. Let's choose this face. The bold attachment mode is the default. Here, this is the only one available. And we can rotate 90 degrees. And if we preferred, we could move in whatever direction we want. If we wanted this, we could have this. And you're not limited to integers. You can use 0.5 and place it like you want it. I think I'll just leave it at 0. Looks like a little bit closer to the inside. So maybe a 1. Maybe a 1/2 would be better. Alright. And OK. And if we change our radius, I haven't tried this yet. Looks like we would need to go back and change the attachment offset. Put it back to 10. Because the face has gotten bigger, I guess. Alright. Now most of the time this would be a pipe. So we can use the thickness operation. Let's fuse them all together first. By the way, if you don't like looking at these seams, there is a view mode in the toolbar here. We can choose shaded, and that will hide those seams. So if you want to take a screenshot or something, you can remove them like that. You can also access that in the View tab. Display mode, shaded, flat lines is the default. Flat lines or as is. Other options. Let's go up here and look at some of the other options. The wireframe shows you just the edges and the vertexes. Points shows only the vertexes. Can be useful if you're trying to select a point and there's something in the way of it. That's a hidden line, and that's no shading. Alright, now we can use our thickness to create the pipe. Select the faces where you want the holes and the thickness. And the reason it failed, this needs to be a negative value. And I like to choose intersection and OK. It appears the holes are still full because when it failed, it did not hide the fusion. So we can hide the fusion object. And now we have a pretty good looking part. Let me hide this, clear this, so if there's another error, it'll catch my attention. There is a tool we can use in the view menu called the clipping plane. I'm going to choose Z, and I'll scroll my mouse wheel up. It gives us a look inside. These are solid walls. This is just a rendering artifact. But I can see I have pretty decent clearance inside. So I'm pretty happy with that. We can choose different planes for the clipping plane. This can be a useful tool. Another tool I wanted to cover is the connect tool. This can be used to connect objects, and it can be convenient for walled objects like pipes. So let me undo the thickness operation. I'm going to press delete. Delete the fusion, and I will fuse these three together. So now this cylinder is a separate object. And apply the thickness. Select the faces. I don't want this to be a negative because I want it inside. I'll leave it at skin and intersection. And do the same for this one. I'll select that face in there. Holding down the control key. Thickness. -1. Intersection. Now let's go for our clipping plane again. And you can see that the pipe sticks into there. Of course, we haven't fused it yet or anything. I actually prefer using the thickness all at once, the way I did it at first. It makes it nice and clean. But the connect tool can do the same thing for us. So we'll select our objects. And we choose to connect the excuse me, connect the objects. And you see that inside of here, you cut away the excess that was sticking in. So that's just another option for how you can connect walled objects together. Let me undo this with the undo operation. By the way, I haven't really covered undoing, but it's very convenient. If you do something and you get an unexpected result, don't panic, just undo it and try again. Let's select them again and choose the embed object. And what this does is just fusing them together and leaving that little bit inside sticking in, which might be what you want sometimes, depending on your model. I would prefer the other option. Now let's look at the third one, which is cutout for object. Here the order of selection is important. I choose thickness first, then thickness 1, cutout for object. So now we see what we need to cut out to make these two parts fit. And if we open this up and choose the opposite direction, thickness 1 first, then thickness, and do it again, we get the opposite. And if we hide that one, we can examine this one. If we hide that one, we can examine this one. So we could manufacture these parts separately and they would be able to fit together. But whenever you do an operation like this, you have to consider that if the object going into a hole is the same size as the hole, you need some clearance for that. It might just be a tiny fraction of a millimeter, but generally, if you make them both the same size, they'll never fit together. You might have to get a file out or something. So you would want to perhaps adjust for that. Now, I found I use excuse me, ABS printing on my 3D printer with the ABS filament. The acetone, which is basically fingernail polish remover, works as a solvent for ABS, and it's a really terrific glue. So even if I have two parts that are exactly the same size, when I put a little bit of that acetone on there, it dissolves it a little bit, and it'll actually fit. So if I were making this for some project, I would just leave it the same exact size and glue it in with acetone, and it would fit. Well, that's going to be it for today. We have covered using the torus. We've covered attaching objects to other objects. Attaching is something that you would probably use quite often, especially when we get to sketching and using the sketcher, which is a really fun tool to use in FreeCAD. When we get to the part design workbench, which we'll cover after we finish with part, that's a sketch-based modeling style. The modeling style in part workbench is we begin with ready-made geometries, combine them with Boolean operations. We can also do sketch-based modeling in part, and we will do that in the part workbench. But at this point, we've covered all of the primitives. There are some additional primitives we will also be covering. Maybe not as in much depth. I think the next video I'm going to do that. I'll be showing all the primitives that are available, and just a real quick overview of those. We might also look at all of the Boolean operations that are available. The first two that we've covered so far really have only been the fusion and the cut, but there's also an intersection or common and an exclusive OR that we'll look at possibly in the next video as well. The attachment is something that you use very commonly in part design with sketches. We'll often, almost always, attach a sketch to something. Usually one of the major planes, the XY plane, the XZ plane, or the YZ plane. And we'll cover that as we get to it. We also covered today using the cutout tools and showed how they can be convenient for connecting walled objects together. It's not really something, honestly, that I've used very much. I prefer that first method I showed, where we just make it all solid, fuse it, and then use the thickness operation. With thickness, it can be contrary at times. The good thing about FreeCAD is almost always multiple ways to achieve the same thing or something similar enough it makes no difference. So it's good to know all the different ways. So if one is not working for some reason, you can fall back to the other. It's good to know this constructed solid geometry approach, because you might find yourself in a situation where using a sketch-based approach is just not working. So you'll have this to fall back on and use it and get your project done. I'm not suggesting, and I've never suggested, that this approach using geometric primitives and Boolean operations is the best way to model. I don't think it is the best way. Maybe for some models it is, but I think it's the easiest way conceptually to just to get an intuitive feel for modeling. If I had to teach you the Sketcher first, it's a lot of stuff to learn in the Sketcher and a lot of additional operations. So that's why I began with the primitives. I want you to get some early victories as you explore on your own and practice, so you will not become frustrated and just give up. Oh, FreeCAD is just too hard to use, or I can't do this, I'm not smart enough. That's baloney. You do not have to be smart to do this. Okay? This is not astrophysics. You can do this if you have just average intelligence. You're willing to put the time in. There's a lot to learn, but none of it is particularly difficult. So I want you to have some early success so you'll stick with it. Hopefully I haven't gone too fast or too slow. There's always that balance. If you go too fast for the beginners, they can't keep up. If you go too slow, you're going to bore the experienced users. So try to find that balance. We still have a lot to cover in the part workbench before we get to some of the other ones. And we're taking our time and going through it all. I want to be thorough, cover at least briefly, every option available. So that's going to be it for today. I thank you for watching, and as always, have a great day.